Dear students, grade 11. In today's lesson, we're going to start studying about the next chapter about aldehydes and ketones, or about the carbonyl groups. First, just take a look at the learning outcomes for aldehydes and ketones. Describing the formation of aldehydes and ketones from primary and secondary alcohols respectively, using dichromate and acidic or acidified potassium dichromate. The reduction of aldehydes and ketones using NaBH4, or the reaction of aldehydes and ketones with cyanide, hydrogen cyanide, or sodium cyanide. The mechanism of nucleophilic addition. Distinguish between aldehydes and ketones, how to distinguish between them using the Phelan and Tollens reagents. And describing the reaction of CH3CO compound with alkaline aqueous iodine to give triiodomethane. Okay, to study these learning outcomes, of course, we're going to study them for different parts, in different videos. The first thing, let's start to identify what do we mean by a carbonyl group. Actually, a carbonyl group is that group, a C attached to double bond with oxygen. This is called the carbonyl group. Which compounds actually contain the carbonyl groups? Aldehydes, ketones, carboxylic acids. Carboxylic acid derivatives means they have the carboxylic acid or the functional group of carboxylic acids, but like acid halides, acid anhydrides, esters, and amides. For grade 11, in your syllabus, we're going to study only about these three: aldehydes, ketones, and carboxylic acids. So let's start with aldehydes. Okay, we need to know the basic information about aldehydes as any other homologous families that we have studied. The first thing, we have to know what is the general formula, what is the functional group, and of course the naming for that homologous family or that functional group. So first of all, the general formula of aldehydes is CnH2n plus 1 CHO. You can write that as the general formula, or instead of this part, which is CnH2n plus 1, you can use R. R is an alkyl group. It's the same thing. It's actually CnH2n plus 1 is the general formula of alkyl group. So both of these are the correct general formula of aldehydes. Now, what about the functional group? Like any other hydrocarbon, there is a functional group that actually differentiates that compound from many other hydrocarbons. So the family of aldehydes, actually they have one functional group, which is CHO. Okay, so this is about the general formula and the functional group of aldehydes. Now, how we can name aldehydes? Actually, the main principles are still there. You have to choose the longest chain, name the substituents by writing the carbon atom number, and then name the substituent, whether it was halogen or an alkyl group, and we have learned how to name that. If there's a halogen and alkyl group, you have to name the halogen first, and if there's more than one halogen, this is just for reminding, if you have more than one halogen, you have to name them according to the alphabet order. And then if you have an alkyl group with a halogen, you name the halogen first, then the alkyl group. More than alkyl group, also name them according to the alphabet. But don't forget to write the name of the number of the carbon. And then after you write the substituent, you write the prefix, then the name of the chain. The prefix is the name of the chain. Okay, you have from 1 to 10. according to the number of hydrogens, and then you end up with the suffix. Suffix means the final part that actually identify to which family this compound belongs. So for aldehydes, you will remove the E and just add Al. So if you have methane, it will become methanal. Okay, you remove the E. So as an example, if you have methane, okay, if you have methane, it becomes methanal. Methane becomes, when it turns to aldehyde, it becomes methanal. Okay, now here are some notes, important notes, actually, about naming aldehydes. So the functional group in aldehyde is carbonyl group bounded to hydrogen and another carbon atom. This means that there is a carbon and there is the HO. This is what it means. Okay. And also one important thing, the functional group of aldehyde is an end group. So when you start naming, you have to count starting from the aldehyde group, like here. You have 3 carbons and this is the aldehyde functional group. You always start from the carbon in the functional group of aldehyde. Here are some examples. Okay, this is the first one, methanal. Okay, before it was CH4. So now you have carbon attaching to double bond with hydrogen and H. So here you have 3. So methanal is CH or HCHO. This is methanal. Remember? So we removed the E and we just added Al. This is ethanal. This is the R group and this is CHO. And also this is the R group. This is only different because there is only hydrogen, only different for methanol. But in propanol, it's the same. You have, this is the alkyl group and this is the functional group. Now, let's try these examples. Remember, we said we have to choose the longest chain. That's one thing. Second thing, we also have to start from the functional group. So the carbon in the functional group is always number 1. So this is 1, 2. We have to start the longest chain. So we're going to try 1, 2, 3, 4, 5, 6. So if you go that way, it's 6 carbons. Okay, let's try another one. 1, 2, 3, 4, 5, 6. It's also 6 that way. 1, 2, 3, 4, 5, 6, and 7. So this is the longest chain. 4, 5, 6, and 7. This is the longest chain. Other than that, these are substituents. Okay, now let's try naming that. Okay, at 5, first we said we have to write the number of the carbon. So at 5 we have 2 substituents, so it's 5 and 5. It's the same alkyl group, so it's dimethyl. And then you have the prefix. How many carbons are there? Actually, it's 7. So hepta. Heptane, right? We will remove the E and instead we will write Al. So it's 5 and 5 dimethyl heptanal. Okay, you yourself, you have to try these examples. Okay, try naming these examples. I will just help you doing, okay, I will do the second one, B. Okay, so this is easy. We'll start from here. 1, 2, 3, 4, and 5. Actually, this is the longest chain. Because if we just move like that, it will be 3. So 5. At 3, we have methyl. So it's 3 methyl. And it's 5, so pentane. Okay, we remove the E and added pentanal. Okay, the rest you try yourselves. Now let's try the basics about ketones. Ketones also, same thing, we will just learn about the basics first, the general formula. Remember when we talked about aldehydes, we said that it's an N group. Basic, it has to be in the middle between two alkyl groups. So here's one alkyl, this is the general formula. One alkyl, and this is another one alkyl, and the carbonyl group, which is CO, or it's the functional group of ketones, alkyl between two alkyl groups. So in naming, we said some things does not change. We use the same steps, but here's one thing. Indicate its presence by changing the suffix. So instead of using AL, we will remove this time the E and add 1. Okay, so instead of methane, it will be methanone. One more thing. We said it becomes in the middle, so we make sure that the carbon in this carbonyl group actually takes the smaller number. So we count closer to the functional group as we used to do. Okay, let's try naming these two compounds. So first we have to pick a side closest to the functional group. So starting by this one, let's call this A and this is B. So if we started from here, so it's 1, 2, 3, 4. Okay, 4 is not the smallest number. If we started from the left, it's 1 and 2. So actually 2 is less than 4, smaller than 4. So it's 1, 2, 3, 4, and 5. In this case, that compound there is no substituent, but you have to write the name of the carbon that has the functional group. Not like aldehydes. Aldehydes actually is an N group, so it's always number 1. That's why we don't need to write the carbon number. But in this case, it's 2. And how many carbons we have? We have 5, so it's pentane. We said we will remove the E and add 1. So it's 2-pentanone. This means that the functional group of carbon number 2, and it's penta, this is the prefix, and this is the suffix. Okay, let's try this one. Okay, actually the functional group is exactly in the middle, so if you count it from here, 1, 2, 3, 1, 2, 3. So we'll pick whatever side. I'll start from here, 1, 2, 3, 4, and 5. So in this case, it's 3, and still it's 5, so it's 3-pentanone. Again, you have the prefix and you have the suffix. Here's also some examples to name the following ketones according to IUPAC system. Okay, I will help you just doing 1. So I will do B, same. So we said we'll start closer to the functional group. If we're moving closer, so this should be the 1. 1, 2, 3. So it's definitely 1, 2, 3, and 4. 2 is the smallest number. So it's 2, and we have 4 carbons, no substituents. So it's 2, 4. Butane, and add 1, so it's butanone. This is our lesson for today, and hope to see you soon.